Hey everybody, it's Professor Capko again. In this video I want to talk about slope. Slope is something that you will deal with in algebra, and I want to show you a couple ways to tackle it. Alright, first of all, we need to understand what slope is, so you'll see oftentimes what's called a coordinate plane like this. And you've got the x-axis and the y-axis. Now this one came already labeled, but it's always a good idea to label it so you know exactly which is which, because students often get confused. Alright, so we have coordinates that will tell us where to plot things on our coordinate plane. And those plots, those points that are plotted, oftentimes create a line. So if we have a line, we want to know its slope. So if we look at what a slope is talking about the rise over the run. The rise over the run. So let's talk about what that means. Let's give that easy definition there. Slope, and usually the abbreviation for that is M, is equal to the rise over the run. Now there's several different ways to figure out what slope is, and I want to show you at least one in this video, and we could talk about some other ways in other videos. Alright, so when we're talking about rise and run, I like to talk about the run first, and for purposes of my classes, I always like to have students run left to right. Left to right, just like you would read. Now, I know that you can calculate slope going from right to left as well, but let's not complicate things unnecessarily. Let's just always think in terms of going left to right. That will simplify things for your problems. Also, we're always going to talk about rising up. Always rise up. Now, in some cases, as you'll see in a moment, the line is going down as you're going left to right. Well, that's rising up in a negative direction, so we'll wind up with what's known as a negative slope. Let me show you some examples here. Alright, here's my coordinate plane. If I have a line that looks like this, for example, and it's a line that's got arrows on both ends, and you want to know what type of slope this is, before we even calculate it, I'm going to go left to right, and as I go left to right along this line, which direction is it going? You're right, it's going up. So this type of line has a positive slope. It's a positive slope. And whenever you're going to figure out the slope, go ahead and first take an estimate of what it is. Is it going to be a positive slope? Then put that and mark that down somewhere. So that way, if you go through all the work of figuring out the slope and you wind up with something other than a positive slope, you will know you've made a mistake somewhere. Okay, so that's a positive slope. Let's look at another possibility. Let's say you have a line that looks like this. Well, as we're going left to right, going down the line, it goes down, like a down escalator. So a line such as that is said to have a negative slope. So looking at the line in your book or on your problem, right off the bat, you should be able to tell if it's a positive slope or a negative slope. And again, write it off to the side, so that way when you do the calculations, you know you've gotten it correct. Here's another possibility. Let's say you have a line that looks like this. It's exactly horizontal. It's exactly horizontal along the, just like the x-axis is. Well, this is not going up or down. It's horizontal. It's exactly level, just like hopefully the floor of your home is. So that would be zero slope. It's got zero slope. No slope at all. And one other possibility, again, you want to jot these things down, would be a line that looks like this. Perfectly vertical. And if we're looking at the rise or the run, well, is it sloping up or is it sloping down as it goes left to right? Well, first of all, you can't go left to right because it is all up and straight up and down. So you could say that it's going up and down at the same time, and therefore it has what is known as undefined slope. And perhaps another video will actually prove that to you, but this has an undefined slope. Now, a good way to remember the difference between zero slope and undefined slope is if you have a zero slope, if you put the zero on there as if it were a ball, it would stay right there. If you had undefined slope and you tried to put the zero or the ball there, it would fall and disappear. Right? So it doesn't hold the zero, so it's undefined. That's just an easy way for you to remember the difference. Not very technical. Alright, let's look at how to figure out the slope just by eyeballing something. Okay, so let's say we have a coordinate plane that looks like this, and I'm going to draw a line. And we're going to figure out the slope of this line using what we know that slope is rise over run. Okay, so we need to figure out, first of all, I want to make a prediction. Is this going to be a positive slope, a negative slope, zero slope, or undefined slope? That's right. As we're going left to right, as you're reading, the line goes up. So this is going to have a positive slope. So I'm going to put positive slope here and just make a little note to myself so I can check it later, make sure I did get a positive. Okay, so the next thing we want to do is look at 2 points on this slope. Any 2 points, as long as they're on the line, any 2 points on the line will work. Personally, I like to pick easy ones. Professor Capko likes to pick easy points on here. You could pick any point you wanted to. Let's pick this point here, and why don't we pick this one here? Those are 2 easy points to look at. The reason they're easy is because this one is exactly where the X and Y axis cross. That is also known as the origin. And actually the point is 0 and 0. And this one crosses here at 4 and 2. You don't want to pick a point here, although you could. Or you could pick a point here, or one out here, or anywhere on the line. The reason is, I don't know what that point is. It's hard to tell. It's kind of in between. It's kind of like 2 and 2/3. I don't know. Why make it hard for yourself? Algebra can be hard enough as it is. Make it as easy as you can for yourself. So I pick these 2 points are easy. So I want to move from one point to the next. But I'm not going to move along the line. I'm looking at slope as rise over run. So my slope is going to be rise over run. I'm always going to run first. You're going to run before you can fly. So I like to move left to right. Yes, you algebra fanatics, you could go right to left. We're going to go left to right. I start at this point and I'm going to move toward this one, but I'm not going to stay on the line. I'm going to go this way. I'm going to go all the way till I'm below this point here. See how I'm directly below it? So I'm going to count how far do I have to run. 1, 2, 3, 4. I ran 4. So that's my run, because the run is lower, right? The run is down below. I ran 4. How far did I rise? I had to go from here all the way up to here. I go 1, 2. I had to rise 2. So I have 2 over 4. That, of course, can be reduced to 1/2. So our slope for this particular line is a positive 1/2. Let's check. Did we have a positive slope? Yes, just like we predicted. So we wound up with a positive 1/2 as our slope, and we now know what the slope is to that line. That slope will be the same anywhere on this line. If we had done this point and that point, we'd get the same slope. So you can pick any 2 points on the line that you want. Professor Capko recommends you pick easy ones. Alright, so that is how you find slope in one method. If you watch the next video, we're going to learn how to calculate slope using a formula. Alright, so hopefully you found that helpful. If you have any questions, go ahead and put them in the comments down below, or you can put another problem in the comments down below and I can solve them for you. And like this video if you liked it. Click the like button. And remember, Professor Capko says keep your grade alive and subscribe. Thank you. Until next time, this is Professor Capko.